Since their introduction, virtual LANs, or VLANs, have provided network engineers added functionality and flexibility in their networks. However, because VLANs are their own broadcast domains, each having their own logical network address space, a Layer 3 device such as a router is needed to route traffic among the VLANs. This video will help you understand the different methods used to facilitate traffic flow from one VLAN to another in a network. Inter-VLAN routing is the process of forwarding traffic from one VLAN to another, and this process requires a router. With traditional inter-VLAN routing, the router uses a separate port for each VLAN. In this animation of traditional inter-VLAN routing, PC1 on VLAN 10 is communicating with PC3, which is on VLAN 30. Notice also that PC1 is at address 172.17.10.21, and PC3 is on a different IP subnet, 172.17.30.23. We know this by looking at the different router interface addresses, which specify a /24 mask. In this example, packets from PC1 flow into the router's F00 interface. The routing process is then completed, and then traffic flows out of the router's F01 interface toward PC3. Note that although we have redundant trunk ports between switches, each router port only participates in a single VLAN. Router on a stick VLAN configuration enables networkers to configure a single trunk port between the switched network and the router regardless of the number of VLANs. The single physical router interface is configured into multiple logical subinterfaces. In this example, you can see that the F01 physical interface has been divided into 3 logical subinterfaces, one for each VLAN. The IP address of each subinterface serves as the default gateway for its respective VLAN. Another option for inter-VLAN routing is to employ a Layer 3 switch to complete the routing function, but this is beyond the scope of this presentation. As you can see, router on a stick inter-VLAN routing provides many advantages over traditional inter-VLAN routing over multiple physical router interfaces, the most apparent of which is cost. Networks with many different VLANs have a high cost if multiple physical router interfaces must be purchased. One drawback of using sub-interfaces is that the VLANs must now share the bandwidth of a single physical interface. However, adding another physical interface can relieve some of this contention. Many organizations use the router on a stick configuration. When implementing traditional inter-VLAN routing with multiple physical interfaces, the interface configuration is no different than applying a basic interface configuration. Each interface gets its own IP address on a different subnet. Separate cables are then used to connect each physical interface to its respective VLAN switch port. When configuring subinterfaces, you must first create the subinterface by using the interface command followed by the interface ID and subinterface ID. In this example, subinterface 10 has been created on physical interface F00. The convention is to match the subinterface number to that of the VLAN ID. For example, subinterface 10 will be used for VLAN 10. Next, use the encapsulation .1q command, followed by the VLAN number that should use this subinterface. Finally, apply an IP address to this subinterface. This IP address will serve as the default gateway for devices on that VLAN. Proper configuration of inter-VLAN routing is critical to ensuring packet delivery among different VLANs. Fortunately, overall configuration of inter-VLAN routing is simple, regardless of which method you employ, traditional or router on a stick. We hope this video is helpful in your continued study of networking. Good luck!